All right, I think we can get started. First off, I want to say thanks a lot for being here today. And then, I think we can get started with my talk. Good morning, good afternoon, or good evening, depending on where you're joining us from. My name is Janani Subbiah, and today we are going to be talking about designing APIs, and we'll also be building one along the way. A little more about me. My name is Janani, and I currently work as a product architect for a company called Detroit Labs, based in Detroit, Michigan, USA. I love to read and travel. I really enjoy the Harry Potter and the Eragon series. Reading has definitely been happening a lot, especially with how last year went. And I haven't traveled in a long time, as I'm sure with most of us. But one of the good things that happened to me last year was I discovered the world of gardening. I don't have a lot of space to grow food, but I have been trying to garden in my balcony, where I just try to grow fruits, vegetables, and herbs from store-bought produce. And it's been so much fun. It's more of an experiment for me than gardening, and I cannot wait for this year's growing season. So in today's talk, we'll start off with some introductions. We'll talk about what APIs are, what REST is, and what, who, and when API design happens. And then we'll go over a 6-step process to designing APIs, and then there'll be a conclusion. So on that note, what is an API? When I say API, I am referring to what's called Application Programming Interface, and think of it as a packaging of some functionality. So APIs, for all intents and purposes, expose functionality as a usable interface. So there are two sides to an API. The people who actually build that functionality and package it into a unit that is usable by the consumers on the other side. Some very popular examples are the collections library from Java Utils, which provides methods for creating or managing, adding, removing, updating elements in collections like maps, lists, and set. Other examples or other type of example would be the APIs exposed by OpenWeatherMap, where these are more HTTP based, meaning that you make a call to the services that are running, and that will then feed you information about weather given coordinates or the location of a place. So those are APIs in a nutshell. Next, let's talk about REST. REST stands for Representational State Transfer. It is an architectural concept. It is abstract, and it doesn't necessarily conform to languages or frameworks, or it is agnostic of languages and frameworks. And it was introduced by Roy Fielding in his PhD dissertation in 2000. And it allows for building systems which are scalable and distributed. It also allows for standardizing communication between software entities. As abstract as REST may sound, there are still some non-optional guiding principles to REST. The first one is REST allows for uniform interfaces, where interfaces can be thought of as very similar to contracts that we write in code. There is a contract that is promised between two parties, one of the parties building it and the other one actually consuming it. Uniform interfaces also allow for both these parties or software entities to evolve independently of each other, so as far as both of them are referring to and building towards the same contract or spec in our case. The next one is client-server architecture. Client-server architecture helps with distributed applications building and also helps with separating concerns. A good example here would be, say you have a client, a web UI client that is responsible for displaying some data for your website, and you have the service running in the background that's feeding up all that data. Because there is a clear separation of concerns in what each of these parties do, the web client is supposed to be displaying all the data and is supposed to be making calls to the service, and the service is supposed to be feeding up all that information. So there is separation of concerns here, and it also helps with building distributed systems where all the functionality is not crammed into a single service. The next one, stateless. And what this means in very simple terms is a request should contain all the information that is required for processing it successfully within itself. It cannot depend on requests that came prior or will be coming afterwards. It should be a self-contained unit. Next is cacheable. Everything on the internet basically needs to be cacheable, or rather, it is important to make sure that we are indicating if a response can be cacheable. So when I say cacheable, implementation-wise, it could translate to cache control headers, which dictate if something is cacheable and how long it can be cached for. The next one is layered systems, where REST allows for functionality to be split across, say, services or servers in general. And a good example is, say, as a client, I'm making a request to a service. I think it's going to go to a single service that's, say, running behind a proxy or a load balancer, but it is possible that that functionality I'm looking for is actually split across multiple servers, meaning one of them could be taking care of authentication, the other one could be taking care of actually receiving the request and feeding up all the data that is required for that request. And there could be a third one that actually takes care of all the storage. There can also be a bunch of load balancers that your request is going to travel through before it actually gets to an end server. And all of this is abstracted from the client. The client doesn't know where the request is going or how it is going to travel through different systems before it gets to an end service. And that's the beauty of REST. All of that's abstracted, but at the same time, it can be layered. And in some ways, this also allows for building services that are more application focused versus having everything like crammed into a single service. Before I get into the meat of my talk, I want to set the stage for what is to come. And I think it's important to differentiate between REST and HTTP here. Actually differentiate between REST APIs and HTTP APIs. When I say HTTP APIs, they are not always purely RESTful. While there are some reasons for this, the top two ones are this. REST does not dictate a particular transport layer protocol. As we just saw, REST stands for Representational State Transfer, and HTTP stands for Hypertext Transfer Protocol, which is a transport layer protocol that is used for transmitting information between entities. Other examples of transport layer protocols are the File Transfer Protocol, and there are several others. HTTP is probably one of the most popularly used one, just because one, it's popular, and number two, the components that are required for building HTTP clients and servers are widely available. I don't know which one came first. Because of those reasons, HTTP is very, very widely used on the internet, but REST in itself doesn't dictate that the transport protocol needs to be HTTP. And the second reason why these are different is because of what is called HADIOS, that stands for Hypermedia as the Engine of Application State. Think of it as additional links to processing resources. So say, for example, you have a service that's serving up all the list of books available in a library. Part of that response, if implemented correctly, and if it is really HADIOS aligned, would be also links that contain all allowed operations on those list of books, meaning operations to probably add a book or delete a book. So in this case, all the client needs to do is probably have a base URL to talk to the service, and all other APIs that the client might need and also allowed operations are actually a part of the response itself in the form of hypermedia links. Again, this is the final level of what's called Richardson's maturity model, and I highly recommend reading it if this is of interest to you. But because of these two reasons, among others, I'm going to go ahead and say today that we will be building an HTTP API service, and we are going to be looking at the different steps that go into building one. The other reason I want to say this is, one, my talk is a beginner's guide. And number two, I want this to be a practical approach where everything I talk about in my talk today is something I'm hoping we all can use in, like, say, Monday or the projects that are happening next week. So for those reasons, today we'll be looking at building an HTTP API service. So on that note, let's talk about what it is. At a very, very high level, when I say HTTP API design, I am talking about identifying resources I want to manage in my system. Resources could be books if we are managing, if you're building a service to manage a library system. They could be users if we are building a user management system. They could be any of those things. So the first step to HTTP API design is to identify what resource we want to manage. And when I say manage, I'm talking about operations allowed on that resource. So I'm going to need a bunch of inputs for that, and I'm going to be producing a bunch of outputs. So this is API, or rather HTTP API design at a very high level. Next, who is it for? It's obviously for developers, because on one side of the aisle, we're going to have developers who are actually consuming this API. On the other side, we're going to have developers who are building the API. But developers are probably the most obvious audience of HTTP API design. It is not specific to developers. It also pertains to other roles. The first one is designers. I think it's helpful to have designers at least be able to read and understand the spec at its most basic level, because design and development definitely go hand in hand if you have a design component to your project. If you don't, maybe it's another team, the services team, that consumes your service. So if that's not the case, it's always helpful to have designers understand what the API is capable of and also point out the things that the API should be doing in order for the designs to work. Next is managers, probably not as much as designers, but I think it's helpful to have people managing teams actually understand API design, because it's easier for them to know progress or for them to have access to these documents if they're required in meetings they go to. The next one is quality engineers, because they're the people who are going to be testing the system, and they're also first advocates for users in any given system. So it's important for quality engineers, again, to be able to understand what the spec indicates so that they can be testing systems and making sure that the builders and the consumers of the API actually conform to that spec. So those would be some of the important audiences for HTTP API design. So the next one is, when does it happen? Ideally, it starts pre-development, just so that you have a spec that has been promised between two parties and both the parties like it and have agreed upon it. That's ideal. And it continues alongside development. It is not very different from code itself, where you build something, you build the first draft of something, and then you receive feedback, and then it is iteratively improved starting from there. And it's iteratively improved. This could be based on maybe new requirements, which could come from design or other consumers, or maybe you've just discovered that certain ways that you've decided to build your service doesn't really conform to security standards and practices. So maybe you want to change things. It could be based on any of those things. But the important point here is it's not set in stone. The first draft is what comes out first, and then it's just a draft from there. It keeps getting iterated upon and improved continuously. So with all our definitions out of the way, let's now talk about the 6-step process to HTTP API design. I want to call out that I believe these first 6 steps will give you a good first draft to build on top of. Definitely not all the steps involved in designing APIs. So on that note, the first step is API naming. And when I say API naming, I'm talking about 2 things. The first one is to actually identify the resource I'm managing in my system. If you have multiple resources you want to build an API spec for, then maybe start with one of them and start with the one that is independent of everything else. So identify the resource that you want to build an API for, and figure out if it belongs to another resource that probably already exists in your system or hasn't been built yet. If it hasn't been built yet, I would say start with the one that's probably the most independent one. And the reason here is this will drive not just how you process the request under the hood, but will also drive how you name your APIs. So once that has been done, make sure to come up with a consistent URI naming strategy. A couple of options here are to use camel casing or to use the hyphenated words. Again, there is no hard and fast rule here. I've seen other options too on the internet. It's just a matter of, I guess, team preference. And if you already have a URI naming strategy going, I would say stick to it, because consistency wins all. It just makes building and using services that are consistent in how they expose APIs very, very easy, because it makes it more predictable for the people building it and for the people consuming it. So consistency throughout, and make sure if this is the first API you're building, make sure to pick one of the options available. So as an example today, let's come up with a resource we want to manage. So I'm going to say I want to manage login history, and say I already have a system where users exist. So I'm going to identify login history as belonging to the user's resource that my system already manages. So if I were to come up with URIs, this would be a URI I would use for representing login histories for any given user with user ID. The user ID there is replaceable with whichever user ID is in context. And if I wanted a representation for a specific login history ID for a given user, this is an API I would use, where the user ID and login history ID will be replaced by the specific user and login history ID. So we're done with the first step of HTTP API design. We've looked at API naming, we've identified our resource, and we've come up with a consistent naming strategy. Next, let's look at HTTP verbs. The second step is to identify all the operations that we want to allow on the resource we have just identified. Four of the very popularly used ones are the post for creating a new resource, the get for fetching either one resource or a list of resources, the put is for updating or modifying a resource, and the delete is for deleting a resource. So when it comes to the second step of API design, the first thing to do is to identify what operations we can allow or we want to allow on the resource we identified in step one. And the second step is to pick the right verb that corresponds to it. Before we get into an example, I want to talk about a couple of HTTP verbs that are probably not as frequently used as the ones we just saw, but these are very close to one of the four ones we just saw. So I think it's important to understand the difference. The first one is the head verb. The head verb is very similar to the get in that the response is very similar, but it doesn't actually contain the entire response of, say, the get request itself. Instead, it is useful in retrieving metadata about the data. So basically data about the data itself. I think an example will help here. Say we had a service that exposed a get API for a resource or a list of resources, and for some reason it just takes a long time to process, or the response is really huge, and the client wants to make sure that there will be a valid response, or wants to just get more information about the response that is to come. The one way to do that is to expose a head API that will have the same URI as the get one, and this fetches all the information about what the response will look like without the response itself. So in a lot of cases, it's usually faster. Metadata could mean maybe content length, or it could be as simple as, will this API request succeed? You know, if I were to make a get request, the head request could give me a sneak peek into, will that my get request be successful? So that is the head verb. The next one is the patch. The patch is very similar to the put in its intentions, meaning it is also used to modify the resource, but how it is done under the hood and the request itself looks a little different. So if you were to look at some diagrams here, let's consider the put as our first example. So we have our HTTP API service that contains a certain version of the resource, and that resource is what we want to update. So we've fetched the current state of the resource, we've made modifications on our client, and that gives rise to the resource outside the service. And now we're going to be making a put call to our service that under the hood will replace the whole resource in its entirety, irrespective of which specific fields were modified. Even if there was just one field modified, the intention is to have a whole new version replace it. But as far as the patch goes, the first difference you'll notice here is the request is not the entire resource. Instead, we identify a specific field or value within our resource that needs to be modified. So in our case, assuming we have a resource and that resource has a field called square, and that's the one we want to update, we can use a patch request to that looks like this. The request can contain the name of the field and the operation, which in our case is update, and then it can contain, or rather it should, in the case of an update, contain the new value that we want to replace the old value with. And assuming everything else looks good, a patch request basically replaces the old value with the new value we passed in. So if you're wondering which one to use because they look very similar and they kind of do the same thing under the hood, I would say a lot of things go into consideration when you're picking between a put versus a patch. The first one is, the obvious one, I guess, is the patch request is probably in some ways not as simple as the put, where you may need a parser to actually be able to read the request. It's not as simple as the request is always going to contain the entire resource. Instead, it consists of the specific name, it consists of the operation, and there can be a lot of combinations there. So depending on how big your service is or how complicated it is, there might be a tiny performance hit there. So that might be something to consider. The second thing is maybe how you have everything stored in your system. Do you have everything in a distributed manner? And, would it be more worthwhile to update a resource in a piecewise fashion versus just updating the entire thing? That's the other one. So there are a couple of considerations there when you want to pick between a patch versus a put. So if we were to circle back and go back to our example of login histories and pick the verbs that we want to allow on our login history resource, let's start off with making an assumption. We want our login history resources to be immutable. We only want users to be able to create a new login history or read the one they've already created. So For the reading part, we are going to expose a get API that basically allows fetching all login history resources for a given user. And there's going to be one more get API for fetching a specific login history for a given user. And for actually being able to create a new login history resource, we're going to use the post. And because we have said we don't want to allow users to be able to update or delete them, the put, the patch, and the deletes are out of the way. So we're not going to use them. So far, we looked at identifying a resource, and then we picked operations that we want to allow on our resource. The next thing we're going to be looking at is the request body, which is going to be the inputs required for managing our resource. So when it comes to the request body, I like to ask 3 questions. The first question is a request body needed? I like to answer this question with another question, which is, am I getting sufficient information from other request components that I might need to successfully process this request? So in our example, if say the user ID and the login history ID for which our API is in context is sufficient to perform that operation successfully, then I'm going to say maybe a request body is not required right now. So that's the first question to ask. Next is to take a look at RFC recommendations. RFC stands for request for comment. And again, it's a central document. I haven't touched on it as much, but I will be leaving a link to it at the end of my talk. It's a request for comment document that has guidelines to building HTTP APIs. It talks about all the response statuses, all the request bodies, and all the other guidelines that might be useful when you're building an HTTP API. So I would say referring to that RFC for everything is very helpful, especially when it comes to the request body, making sure that the verb or the HTTP verb that is in context allows for a request body is helpful. And say you've decided that there is a request body needed and the RFC allows for it, the next step is to finalize a format. JSON, again, is most popularly used, but it doesn't have to be JSON all the time. It can be XML text or anything else that works well for your system and works well for the particular API you're trying to solve. So these 3 questions will help answer if a request body is required. And say we've said yes, the next step is to actually come up with a structure for the request body. So the first thing I like to do here is to figure out what is needed to perform the operation. I like to keep it minimalistic because, again, API design is not set in stone. So if new things are needed, maybe we just add them when they are needed down the road and let the system evolve organically versus trying to solve for all future problems that might actually not be problems. So in this step, we just try to figure out what fields we'll absolutely need to be able to perform this operation. The next step is to come up with validation rules. These could be as simple as just figuring out what is required and what is optional. They could be more complicated, like only allowing certain values for certain fields or interfield validations, whatever those might be. Just coming up with a set of validation rules. And the third one is a word of caution. Just make sure not to avoid duplicating request component values. By this, I mean, say the user ID is coming from the URL as well as the request body. So as far as the user IDs in both these places point to the same value, everything is good. But if they start diverging, then 1, there is confusion on the server side, figuring out which one to use. And number 2, if the server were to just make a call and use one, that might not be what the client intended. So always good to make sure you don't have request components duplicating the same information. And this doesn't just have to be the URI and the request body. It also includes things like headers and anything else that might be a part of the request. So with that out of the way, let's get back to our example. So we identified 2 GET requests in our system, the one to get all login histories for a user and the other one to get a particular login history ID. So the first question we're going to be asking for both these requests or APIs is, do we need a request body for successfully performing this operation? I'm going to say no here because I think for the first case, just having the user ID and knowing that I'm fetching all the login histories for that user is sufficient. And for the second one, I have the specific login history ID and say under the hood, that is how I'm storing them. And that is probably, if I get into storage, if it's the primary key on my login history table, I'm going to say these things that are coming from the URI are sufficient for me to perform these requests successfully. So I'm going to say we don't need a request body. So we're not going to get into a request body for both the GET APIs. The next one is the POST. So the first question here is, do we have enough information to be able to perform these operations? The answer is no, we don't. So we are going to need a request body. And we don't, because the only thing we have so far is the user ID. We don't actually have any information regarding the login history event itself. So we definitely need a request body. The next question is, does the RFC recommend it? Yes, the RFC allows for request bodies in post. So the answer is yes here. And the next one is to come up with a format. So I'm going to pick JSON just because I think it does the job for me. So here is a sample request body that I can use for creating new login histories. I have identified device, time, registered device, IP address, and location as possible fields. I'm keeping my validations very simple, and I'm going to just pick the fields that I think are required and optional. So I'm going to say device, time, registered device, and location are absolutely required. The IP address is not. If the user were to provide it, great. But if they don't, that's fine too. I can still process their request successfully. So that brings us to the end of request body. So we identified login history as a resource. We looked at all the operations we want to allow on login history, and we also talked about some inputs. Next, let's talk about some outputs. The first one we're going to be discussing is the response status. The response status is the first indicator to anybody who's consuming your APIs about if the operation that they were trying to perform actually succeeded, and it plays a huge role in driving next steps. A very common example is where a lot of services and clients use the response status to figure out if that request needs to be retried. That's just one example. I'm sure there are several others, including things like maybe a bunch of other API calls need to go out depending on whatever error happened, or maybe a bunch of updates need to happen on their side depending on what the status was. So irrespective of which one it is, the response status is the first peek into what happened with the request. Was it successful? And it drives next steps. And there are two big categories of response statuses. The first one is the error status code. Again, there are several other error status codes. Today, I'm going to focus on the 400s and the 500s because I think understanding them is very helpful. And they're probably the first ones you'll be using in your service. The 400 series basically indicates a client level error. So somebody who's consuming an API, if they see a 400 from the service that actually serves up all information, it means that some data that was presented as a part of the request is incorrect. Some popular 400 level errors include the 400 itself, which is a bad request. There's 401, which means the credentials presented were incorrect, so it stands for unauthorized. 403 is when somebody is trying to access a resource they don't have the permissions to access, and it stands for forbidden. 404 is not found, and those are some examples of a 400 level error. As far as the 500 ones go, it indicates a server level error. Something on the server side went wrong, and the client necessarily doesn't have to make changes right now to the request that they're trying to submit and get a successful response for. The popular one is 500, which stands for internal server error. And those are 400s and 500s at a very high level, and they mean different things. The success status codes on the other side are, again, I guess the most popular ones are the 200s, which means literally okay. And it is usually used with GET requests, where, we're indicating to the client that everything went well, and here is the response for your request. A 201 is usually used for creating requests or for the post HTTP verb. Again, it indicates that not only was the request successful, but as a result of the request, something on the server changed. In most cases, for a post, a new resource was created. So that's what it indicates. A 204 stands for no content, usually used with deleting a resource. And what that means is, as a result of this request, something was deleted, but there is nothing for the service to respond back with, except a 204. So there is usually no response body with the 204. The consequences of mixing up error status codes is far more far-reaching when it comes to the error ones versus the success ones. I think as far as the success one goes, it's always helpful to pick the status code that indicates more precisely what the success, what the category of the success falls, which bucket it falls into. But if you were to mix up a 201 versus a 200 and basically pass back a 200 for a post request, the consequences are probably not as drastic. But if you were to mix up those response statuses within the realm of the error status code, say the service decided to pass back a 500 when it's actually a 400, and the client always retries on a 500, the client's now going to keep retrying a request that's never going to succeed because something needs to change on their side, and they don't know that something needs to change on their side because the service messed up and passed back the wrong status code. So as far as error status codes go, my recommendation is read through the RFC, read through just HTTP statuses in general to understand which status actually most precisely reflects the error you're trying to convey. And in a lot of cases, usually error status codes could be accompanied by a response body with more information, but it is also important to pick the right status code. As far as the success one goes, I guess it's nice to have, again, a more concise status code be passed back depending on the operation that was performed, but that's more nice to have. So if we were to look at some examples for response statuses and the error ones in particular, say a user is trying to create a new login history resource and they don't pass in the device field, which we have identified as a required field, they should be seeing a 400, which stands for bad request, and it indicates that something in the request body was incorrect. And the status code can also be accompanied by a response body that contains more information. Maybe it can see something as simple as device was not provided. So that's one example. The other one is, say if a user is trying to fetch login histories for another user who actually doesn't exist in the system. So basically using an invalid user ID, they should see a 404. That means basically that the resource that this user is trying to access does not exist in the system. And as far as the success ones goes, say user A is trying to access user A's login history resources. In this case, the status code should be a 200, and the response body should contain the list of login history resources that user A is trying to access. Another example is when user A tries to create a new login history resource again for themselves, they should see a 201, meaning everything went well, and the request was successful, and something on the server changed. Basically, a new login history resource was created for user A. So status check, we identified login history as a resource. We talked about the allowed operations. We talked about the input in terms of the request body. And we also partially talked about the output. The first output we talked about was the response status. Next, we're going to be looking at the response body. For the response body, I am going to start off with a word of caution. Make sure that the response body is on par with the response status code. And what is a big no-no here is if you were to pass back, say, a 200 as the response status, but your response body actually contains an error, that is just so confusing and it makes no sense. It's very frustrating to work with. So always make sure that your response body, if it's a success, then it contains a list of successfully returned items. If it's an error, then that is what is indicated in your response body. Make sure to have your response status and your response body be on par with each other, because after all, they together form the output of the system. And the second step, or rather the first step in actually figuring out the response body, is to decide what information actually needs to be sent back. Again, I like to keep this minimalistic to start with and not plan for things that might never show up in the future. So I like to focus this on what is required to be passed back for, say, the UI or other consumers. This could be driven by design. This could be driven by requirements from other consumers, depending on how you're building a system and what your API service does. Another suggestion, I think this is just a personal preference. I like to always look for places where I can break up my API responses versus, having a single API serve up all the possible information. I guess a good example here is if you had a list of items displayed on the UI, again, assuming your project has a design component, and in that design component is one page where you have a list of items, and each of those items in the list are clickable, and you click on them, and that takes you to another page that gives you more information about the item that was clicked. We can do this with two APIs. The first one is the very pared down version of all the entities or resources that need to be displayed on the list itself. So this is not going to contain everything about that resource. And the second page can contain additional information depending on how things are displayed. So that's just one example where breaking up the APIs versus having the first API pass everything back is helpful. So in that spirit, when, say, we have a UI component and we want to be able to fetch all login histories for a given user, here is a sample response, which is, it doesn't contain all the information that is all the login history related information for the resources. Instead, it only contains 3 fields, probably driven by design again. And if the user were to fetch more information about a single login history resource that can contain more information, like the one shown here. And for the post, again, assuming that we are not handling any sensitive information and the newly created login history can actually be passed back to the client, here is an example of what that would look like. The only field we'll add is the ID itself. That ID, in this case, refers to the ID that the resource was probably given when it was created in the system. Something to keep in mind for returning response bodies for post is make sure that you don't have any sensitive information here, especially if you have things like card information or whatnot. Make sure to thoroughly read through all the PCI compliance, which is payment card industry. They have a set of rules for displaying or not displaying certain information. So general rule of thumb, always good to make sure your response body doesn't contain any sensitive information. So with that, we are almost done with the 6-step process. We are finally in our 6th step, and we're going to be talking about path versus query parameters and which ones I like to use where. So for path parameters, I like to use all the unique identifiers as path parameters. And I also like to make sure they're nested appropriately, which is probably the best way to do it. And when I say nested, I guess I'm talking about putting them in a sequential order, the same order in which they probably belong to each other. If we were to consider the APIs that we were working with, we have users followed by user ID, and then we have login histories. And that basically says a story, right? It says that login history belongs to users. So make sure to have your query parameters nested correctly. So if user ID make sure to have your path parameters nested correctly. If user ID is a path parameter, make sure it comes after users and before any other resource that might belong to the user resource. As far as query parameters go, they're great for functionalities like searching, sorting, and pagination. So if we were to look at examples in the system that we just built, we have a couple of APIs here where the user ID and the login history ID are examples of path parameters. And if we want to talk about query parameters and say we wanted to make our system more fancy and implement searching, here is an example of an API that we could use for searching through login histories, where we want to search by a device. It doesn't have to be a single value for device, and it also doesn't have to be searching by just device. This can be a bunch of search criteria, meaning we can search by device and time and IP address, and they can all be just separated after the question mark in the URI. By an ampersand. So that is an example. And again, device also doesn't need to just contain one value. It can have iPhone, maybe Google phone, and anything else like that. And as far as sorting goes, here is an example of how we could expose APIs for sorting. I like to use the ascending or descending fields because I think it's a lot more obvious which fields are being sorted on. Some applications also do the plus or the minus. I guess it conveys the same thing, but I just like this better because it's more obvious in the face. Once again, very similar to the searching APIs, these don't have to contain a single value. They can have multiple values, and sorting can happen consecutively. So if we had time and device, and if the time stamp on two different login histories were the same, then they can be sorted within that set based on the device on the login history. And the same thing for descending. And if we were to include pagination in our API service, here is an example, a very simple example of how pagination would look, basically just trying to fetch the second page for login history resources of a given user. Another parameter that might come into play as far as pagination goes is the results per page. If we want to allow the client to be able to take control of how many results they want returned per page. So with that, we've gone through the 6 steps of HTTP API design. I want to talk about what's next. A couple of things that we didn't touch on, but I think are very important as things that could come next are security. Security is a huge part of any application. It's one of those things where there are many options, but at the same time, there are just so many other options for malicious attack and things to keep track of. So as you're adding security to your system, not only does your system change, but your spec also changes. A good example is if you have a layer of authentication followed by a layer of authorization, where first the user has to present the right credentials and prove who they say they are, followed by making sure that they have permissions to access the resource they're trying to access. your response body is going to be different depending on which layer they've got through. Maybe if they aren't authorized, but they're authenticated, you should be passing back a 403 versus giving them more information about the system, maybe not a 404, even if that user ID that they're trying to use is invalid. So things like this, especially the response status and the response body change depending on how you decide to implement security on your system, and depending on how much of, depending on the sensitivity of the data that's being handled. And the other thing we didn't touch on today was headers. Headers are like the silent things in your requests. They will be passed in whether you use Postman or your browser, and they can be used for a lot of custom things and are. So understanding how headers work and understanding the default ones, again, the RFC here really is very helpful, is very useful in understanding how you can use them in your system and where they make, I guess, a good choice of a request component. So on that note, I have reached the conclusion of my talk. We start off with some introductions. We talked about REST APIs and REST in general, APIs and API design. We talked about who it's for, when it's done, and what it is. And then we talked about the 6-step process to HTTP API design. We start off with identifying a resource, identifying the operations, and identifying the input in terms of the request body. And then we talked about output components. We talked about the response status, error versus success ones, and which ones best fit different scenarios. And we also talked about the response body. And finally, we talked about the path. We talked about path versus query parameters and which one fits where better. And if there's one thing that you all take away from my talk today, I hope it's this. There exists an RFC, which is the central document that is referenced by several developers who are building APIs just like each other. And that RFC is going to be your friend when you're building a spec, because it has all the information that you might need, be it picking the right status code or picking the right HTTP verb. It's going to have all that information there. Please use it as your friend. It's a reference and it's there to help you. So thanks a lot for being here. I really enjoyed my talk. I hope you did too. If you have any questions, I plan on hanging out here for a little bit, so feel free to ask away. I will be monitoring the chat on WebEx and Slack. So if you have questions there, I'll be more than happy to answer them. If you have any other questions or feedback come up later, I am Janani_Subbiah on Twitter. So please feel free to reach out to me. I'll be very happy to hear from you. Thanks and have a wonderful day.
That was excellent, Janani. Thank you so much.
Thanks.
Folks, if there are any questions, feel free to unmute, say hello, ask your questions here. Or as Janani says, we can pick up questions in chat or in Slack. There's always a moment now when you wait to see whether people are reaching for the unmute button or everyone just, they get it and it's all fine.
I like to think everybody's getting it.
So there's a question from Peter Simpson in the chat here. Says, do you version your REST APIs?
That is a great question. I have worked with APIs that have been versioned. I've been, I think, in a lot of conversations where it's turned into like really heated conversations with a mention of some, I guess, trigger words, for lack of a better word. No, but I guess I'm curious to find out if you're thinking of what options would be best to pick, or, is there another question like within versioning itself?
So maybe just a sort of interesting spin on that is, when you put an API into production, do you do anything in case you need to version it in future?
I guess that is something I have to think about, because there are just so many ways of doing it. I think the URI is very popularly used for versioning, but I think not a problem, but something that needs to be taken into consideration with URI-based versioning is how you deploy things or how you want to deploy them. Headers is another option, and I think I personally like using headers for versioning, because I think URIs need to represent like your resource under the hood. And I don't think versions are really a part of that, but that's just a personal preference, so I'll say that too. Yeah, does that help for the question?
Peter, I assume so. Tom has a question come up in chat about, you showed us atomic operations on resources. What about bulk operations on resources? And then an e.g. API/SKU/recalculate price ...
So is the question again, like, how we would design that, or?
Yeah, I guess so. It's Tom, you want to unmute and jump on and elaborate a little?
Yes, the question is, how do you go about that in terms of naming and designing the API? Because it's not really attached to a HTTP verb. It's rather an operation on a set of resources. So what is your take at that?
That's a great question. I think the first question I would ask for operations like that is, does it actually change something under the hood? Is it creating new resources, or is it, is it just a facade for a bunch of operations? And a lot of times, I've also seen this done like that. The other option is to look at it from a client's point of view. If somebody is trying to say recalculate prices, what are they getting? Are they getting a list of new prices? Are they creating a new order? And if there are multiple of them, I think sometimes I like to look at the one that's probably of the biggest value to the client. Maybe if they're trying to recalculate prices, fetching the newly calculated prices might be the biggest operation there versus anything else that might be created as a part of that. I think that is I guess I thought about this in 2 minutes answer.
One interesting, just Tom, something you said there is about, what if it's not a resource, it's a list of resources. One of the things that I found really changed the way I think about building APIs is, no, there is a resource and there is another resource, which is a list. So there's a customer and there's a customer list. And if you're used to, conventional programming, you're like, oh, it's just an array of customer. But actually, once you start thinking, no, a list of customers is the customer list is a different kind of resource. It's addressable. It has its own URI. It has its own operations. And then you can sort of start thinking, so now it makes sense to say patch a price list and perform some operation on it. I thought that was really great talk. There's a lot of stuff in here I wish somebody had told me when I was first starting out, because I spent a lot of years getting all this stuff wrong the hard way. So
that definitely makes two of us. So I'm glad you found it useful. Thank you.
Actually, just as a suggestion in the chat, version and deploy your two versions so you have strategy and experience in versioning. The best rule of versioning is don't do it if you can possibly make everything future-proof, but eventually reality will bite you. Any other questions in the chat, folks? If not, thank you very much, Janani, for... Oh, was that a question?
Yeah, I have one question around how can we allow our first-time consumers to kind of explore our API in a lower environment? So they go to our website, they go to our documentation. How can we make them sort of use different versions or different environments?
That's again a great question. I think if you're getting into tools, Swagger Hub is very popular. And Swagger is also very popular if you want to spin up your own mock Swagger service, and it has an option in there to be able to pick between environments. So they can not just, and if you have the right URI for your environments, they can explore APIs in, say, the test environment or in beta or in certification and in production. So that's one option. I guess in a lot of places, the other option is to actually give them an entire spec, which is just a spec, but is not backed by any service. So it's you just have to believe that the spec contains all the true information versus actually knowing what is returned. And I have used this with Swagger. So that's the first example that comes to mind for exploring actual APIs under the hood, making actual API calls. I'm not sure. I'm sure there are other tools. I'm just not sure what they are.
Thank you.
Thanks for the question.
All right.
Cool.
Let's wrap it up. Thank you so much, Janani, for speaking and being part of NDC London 2021. Thanks, everyone, for coming along. We have